here we go. So I have 3 raised to the 6x minus 2 equals 1/9 raised to the x plus 1. So we've been talking a lot about keeping the exact same base, right? If I can have the exact same base, then I know that the exponents are going to be exactly the same, or at least going to be equal to each other, not exactly the same. But then we can use that power of equality to help us solve for the rest of the problem. Now we got an issue here because I have a whole number as my base over here is 3. And I have a fraction or a rational number as my base over here. So I need to kind of remember a little bit of the rules of exponents to be able to help me try to see how can I get these to be the exact same base. So first of all, let's just kind of remind ourselves, if I have x to the negative m, that equals 1 over x to the n, right? So this has become very, very important. If I also said 1 over x to the n, then that's equal to x to the negative n. So therefore, I can rewrite this problem as 1 over 9. I can rewrite that as 9 to the negative first power. And that's become very important because if I now rewrite this as 3 to the 6x minus 2 equals 9 to the negative first raised to the x plus 1, now I at least have them both as whole numbers. But now I see, all right, now my base is 3 and it's 9, right? And even though it's raised to 2 more powers, I have now 2 bases of 3 and 9. So how can I now rewrite them so they're going to be the exact same base? Well, I know that 9, I can rewrite that as 3 squared. And that's when I write it as 3 squared, now it has a base of 3, which is exactly my base over here. So what I'll have is 3 to the 6x minus 2 equals 3 squared raised to the negative first raised to the x plus 1. And you might say, well, okay, you got way too many multiplications going on. But remember the power of power rule, which states if I have x to the m raised to the n, that equals x to the m times n. So what I'm simply doing is multiplying 2 times negative 1 times x plus 1, which I'm going to put in parentheses to make sure I remind myself to multiply this all the way through. So really I can rewrite this as 3x minus 2 equals 3 to the negative second power times x plus 1. So I just multiply the 2 times negative 1. Now I notice I have the exact same bases. Therefore, we know that the exponents are equal to each other. So I can write 6x minus 2 equals negative 2 times x plus 1. And now I just need to solve for x. So I apply distributive property, and I get 6x minus 2 equals negative 2x minus 2. Get the x's on the same side, so I'll add a 2x on both sides. And I get 8x minus 2 equals a negative 2. Add 2, and I get 8x equals 0. Divide by 8, and I get x equals 0. So, ladies and gentlemen, it's very important when dealing with this, especially when you have a whole number and a fraction, to rewrite your fraction as a whole number with the negative exponents, and then make sure you get them to be the same base, and just make sure you apply your power of power rule, and therefore you go ahead and solve. So it looks like everything looks good. So there you go, ladies and gentlemen. That's how you solve the problem. Thanks.